All right. From last section, we talked about center of the data set. So we talked about mean and median. They measure where the center, one number that represents the whole data set, which we pick like a center of the data set. Today we'll talk about this thing called measure of spread. Basically, by the way, this corresponds to section 2.7. So once we have the center of the data set, we want to measure how data values are spread. So how data values are spread from the center. Right? Are they all bunched up together like this, or are they more spread out like this or like that? Right? It tells you another interesting property of the data values, so that's what we're going to study today. Another way to think about it is called how much do numbers vary? How much do data values vary? Right? So either we're talking about spread or vary. There are a bunch of examples. I'll go over a few. They say to arrange 4 examples A, B, C, D from the least spread to the most spread. So imagine these are people's like income, hourly income. Each dot represents a person, right? So if you look at example A, group A, there are 1, 2, 3, 4, 5, 6. There are 6 people. I can see 6 dots on top of 10. So my interpretation here is, there are 10 people, and there are 10 people. Sorry, not 10 people. There are 6 people. They all make $10 an hour, right? If I were to look at example B, again, example B has 6 persons, like 6 people. There's a 1, 2, 3, 4, 5, 6 people. This person makes only 7. This person makes 13. So you can see there's a little bit of a spread. Like your data values are like 7 all the way to 13. Right? So here my interpretation is like, this person doesn't make that much, only $7. This person makes $13. Right? So imagine this was like the average person was 10. Then I can see how B, there are people who are making way less than 10. The people making a lot more than 10. So this one has more spread. So if I were to arrange them in terms of how much spread they have, this population A, or does data set A doesn't have any spread. Everyone makes exactly the same amount of money. That will be my A. I'm looking at data set B, C, and D. I feel like this one has the most spread, like 7, 8. There are 7 and 8. They're so far away from 10. So I feel like B is the most spread, right? And then C will be the somewhere in between. Another way I can kind of think about this is, are there more middle class versus like poor? Do we have a lot of poor and rich, right? If there's a lot of middle class, that means it's like at least less spread. Means like wealth is spread more evenly. If there's a lot of poor people and there's a lot of rich people, that means there are more spread. So I'm gonna have you guys work on number 2 and number 3. All right, now we look at number 4. So more systematically, instead of looking at the graph and the dots, for this class, we're going to calculate a particular number to decide if our data set has a lot of spread or not a lot of spread. So the number we're going to calculate is called standard deviation. So we have a sample standard deviation, is denoted by S. Oops, where's pen? S. And then if the standard deviation comes from population, POP means population. Population. So population standard deviation is denoted by sigma. Again, it looks like 6 kind of sideways. And sample variance is denoted by S squared. And the population variance is sigma squared. It's called sigma. This is a Greek letter. It's like 6 sideways. Sigma squared. It literally means squaring the numbers, so number times by itself. Most likely, in our class, we're going to deal with standard deviation and the population estimation more often than variance. So we just need to know what variance is, but we'll be using standard deviation a lot, and either sample or population. And again, we'll make a big difference. We'll make a big deal about, is it from a sample or is it from population? Okay, 5, not really important. A measure variation is a number that tells us the amount of spread. Oops. Or what? I don't know. I think I just meant to say that. That's it. How is range calculated? Range is just the largest number minus the smallest number of the data set. So pretty simple. Next topic is population standard deviation and the sample standard deviation. There's a complicated formula to calculate it. We're not going to deal with it. We're going to use TI-84 to calculate it, so we don't really need to know, but in practice, we'll use a calculator function key. Calculator gives you, when you input data and calculate standard deviation, calculator will give you 2 answers. One is population standard deviation, the other one is the sample standard deviation. Because calculator doesn't know if the data is population or sample, you have to decide which number to use. So it could be misrepresenting because the calculator will just give you 2 numbers. So you have to kind of pick which one to use. Depends on if the data was population or sample. So we're going to be careful with that. And we kind of already know the calculator function key. So this is the same as how we calculated the mean and the median and then quartile. So we'll use stat function key, then we'll go to calculate, and then we'll do 1 var statistics. And from there, we'll read off either SX or sigma x, depends on what we have. I guess I answered the next 2 questions. Population standard deviation, again, is a sigma, but calculator has a little x attached to it. And the sample standard deviation is S, and again, this calculator has a little x attached to it. And to calculate the variance, we simply square the standard deviation. On your calculator, you can calculate the square by using the x squared function key. So basically what standard deviation calculates is the spread. So a larger standard deviation means more variation and spread in the data set. The way the standard deviation is calculated, standard deviation is going to be always positive. So standard deviation can be negative, that's false. It's always positive. Standard deviation is sensitive to outlier, that's true. If you have a 1 big number, your standard deviation is going to come out very large. Standard deviation can have units that are different from the data set. It should be the same, false. This part you don't have to worry too much about it. This part you just have to worry too much about it. What does it mean to have standard deviation equal to 0? That means there is no variation or spread, that means all the number in the data set is exactly the same. Just like the first example we did where everyone was making $10, that data set had zero spread or zero variation. So that means every data set value are equal. Basically everyone's making exact same amount of money. That means you have zero standard deviation. Alright, now we know how to calculate the standard deviation. We're going to try to use that in some ways. And one use for standard deviations is to find out what the outlier is. Before we use the IQR method to find the outlier, here we're going to try to use we're going to incorporate standard deviation to try to find the outlier. So another way that we can measure the relative standing of the data value is to calculate the z-score. Here we're going to talk about z-score a little bit, and we're going to do something else, and then towards the end of the middle half of the semester we're going to talk about z-score even more. So this concept will come back. It measures the number of standard deviation x is above the mean, which is used by symbol mu. If z-score is negative, that means x is below the mean, and if the z-score is positive, then x is above the mean. So how do I calculate the z-score? Z-score is calculated by take a number x, subtract the mean, divide by the standard deviation. So that's like a number x minus the mean, divide, I'm going to put the parentheses around, divide by standard deviation. Same thing for sample. It's the same formula, but we have to label it differently. Z-score, if you have a sample, take a number, subtract the mean, x bar, and over s. So it's exactly the same thing. You notice that formula is basically the same, but we just call it different name. There's mu for population, there's x bar for sample, there's sigma and s. So again, z-score kind of tells you your relative standing. So if we kind of draw the graph, oops, use blue one. I'm kind of explaining the next part, but graphically. So when you calculate z-score of any number, most likely you're going to get something close to 0. You might get 1, you might get 2, you rarely get 3, and so on and so forth. You might get 1, 2, 3, -1, -2, -3. So most of the answers you're going to get when you calculate z-score is going to be somewhere between 0 and 2 maybe. These are going to be like a normal value. Normal values. It's rare, but sometimes your answer is going to come out more than 2, like 3. This is pretty rare. Same, sometimes you're going to get -2, -3. That's going to be pretty rare. So just know that what's going to happen. So if you look at the next part, what does it mean to have z-score? If it's equal to 0, that means you're exactly the mean. So here, maybe I should write it here. Mean is right in the middle. Again, we're trying to see how things are spread from the mean, right? So if z-score is equal to 0, that means x is exactly the mean. So what it means is, let's say you got your test score, and you calculate your own score. So basically take your own score, subtract the average, divide by standard deviation. If it comes out to be 0, that means you do have an average score. So what you got is exactly the average. But if your z-score is positive, that means you're above average. Yay. Oops, average. And if your z-score is negative, that means you're below average. but you can do better next time, right? Below average. So closer to 0 means you're closer to average. If you're 1, you're somewhat over average. If you're 2, that's pretty good. If you're over 2, that means you're way above average. That's pretty rare. So you did really well. So here, larger than 2 means you're way above the average. So this is kind of like an outlier too, because the outlier is a number that is either way too big or way too small. So I can kind of interpret it as like, well, isn't it same as the concept of outlier? Yeah, pretty much. Same here. If it's less than 2, you're way below the average. Also, I can consider that as an outlier. Between -2 and +2 is just like, normal value, right? Okay, then we're pretty much done. I'm gonna have you pause and finish the rest of the worksheet.